Okay, in this example, we're going to solve cot 2 phi minus pi over 3 equals root 3 in the interval 0 to 2 pi. To start with, we're going to use the fact that cot of something is 1 over tan of the same thing and take the reciprocal of both sides. That gives us tan of 2 phi minus pi over 3 equals 1 over root 3. From here, to get a solution for 2 phi minus pi over 3, I can just do inverse tan of 1 over root 3. Remember, in this question, it's asked us for exact values. So if we do inverse tan of 1 over root 3, that's just going to get us pi over 6. Now we're going to have several other solutions for this. Before we go ahead and work them out, we're going to think about two things. First of all, we're going to think about how many solutions do we expect to see. And then we're also going to have a look at how can we do this efficiently on our calculator so that we have to type less things in. Well, if we were going to solve an equation with, say, tan phi in between 0 and 2 pi, normally we would expect to see two solutions. So if we're going to solve something involving 2 phi, we would expect to see 4 solutions. The minus pi over 3 won't really affect things because it just shifts the graph to the right by pi over 3. So, to get more solutions for tan, we need to either add or subtract multiples of pi from whatever we've already got. If we were to subtract a multiple of pi from this, that would get us to minus 5 pi over 6. And then if you think about the fact that if you add pi over 3, you would still be negative, so it would be outside the region. So instead, we're going to add several multiples of pi. First of all, store this value in your calculator, say as a. And then if you open up a list, you can put a as the first value, and then put a comma in. And then the second value, you can do a plus pi. And then the third value, a plus 2 pi. Fourth value, a plus 4 pi. Here, though, they're relatively easy for us to just write down. If we add pi onto that, that's going to get us to 7 pi over 6. Then if we add another pi onto that, that's going to get us to 13 pi over 6. And then a further pi would get us to 19 pi over 6. So now all we need to do to our list in our calculator is add pi over 3 to it and divide by 2. That would give us phi equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So there are our 4 solutions to the equation given as exact values. In a moment, I'm going to put a second problem up on the screen. You might want to have a go at that first for yourself before coming back and checking the solution against mine. Okay, in this problem we've got cot of 2 phi plus pi over 6 equals 1 in the interval 0 to 2 pi. So we're going to start by taking the reciprocal of both sides. The reciprocal of cot can be tan, so we're going to write this as tan of 2 phi plus pi over 6, and the reciprocal of 1 is just 1. Next, we're going to find the principal solution for 2 phi plus pi over 6 by doing inverse tan of 1. If we do that as an exact value, we get pi over 4. Again, like in the last problem, we've got tan of 2 phi, so we would expect to see 4 solutions. If we subtract pi from this one, we're going to get minus 3/4 pi, and then we're going to subtract pi over 6, still going to be negative, so we don't want to be doing that. So next up, we're going to keep adding multiples of pi. Remember, store this one in your calculator first as pi over 4, and then do pi over 4 plus pi, and then another pi, and so on. So if we do pi over 4 plus pi, we're going to get 5 pi over 4. If we add another multiple of pi, we're going to get to 9 pi over 4. And if we add another multiple of pi, we're going to get to 13 pi over 4. From here, take the list on your calculator, subtract pi over 6 from it, and then divide it by 2. If you do that, we're going to get theta equals 1 over 24 pi. We're going to get 13 over 24 times pi. We're going to get 25 over 24 pi. And 37 over 24 pi. And they are our 4 solutions given as exact values.